Hi friends, so now we will do some hands-on with NumPy, right? So as we have already discussed about NumPy thoroughly, now we will check the how we can apply all those concept of NumPy programmatically, right? So yeah, as from beginning, we import NumPy as NP. Okay, so NumPy basically what it does, it is like an array that is a data structure which is used to store value and data type. Okay, while Python list can contain values corresponding to different data types, array is also one of them. Okay, and in Python, NumPy is also one of the famous array by converting a list to an array. Okay, so let's start with an example. Let's say we have a list that contains a few values and there is another list. So in this way we can define any elements inside those list, right? And again what we are doing is we are converting that list into a NumPy array. So to do that, what we do is we define a array. Okay, then we just convert that into NP array, which is nothing but NumPy dot array, right? And for the another, that is number series, also we convert into NumPy array and it will return us as NumPy array. Okay, so now the value got converted with our NumPy array. So let's look with this example. Here we are getting the type of array string, that is our first, right? This is, then we are also getting the type of array num, which is nothing but a list as we got here. Then we are printing the type of our NP array that we converted into NP array, so it will definitely return us ND array, nothing but n dimension array. Okay, so now let's play with the NumPy matrix. As matrix is nothing but it is a two-dimensional data structure, a combination of row and column, and we can also create it using list of lists. Okay, so what I'm doing is I have defined three lists inside a list, and this is nothing but converted into NP array. So system will automatically add them into separate rows. All right, so this is how it forms a matrix here. Now we are again getting the type of that matrix, which is nothing but ND array. Let's say we have several functions in NumPy function. Okay, so how we can use them, as first one is np.arange. Arange is nothing but it gives a range between those values that we pass. So here the syntax is like this: we pass start, stop and step. Start is by default 0 and step is by default 1. Okay, stop could be anything that we want to provide. So here start is 0 and stop is 10. That means 0 is inclusive, I mean the count will start from 0, but the stop is exclusive. Always the index ends here to n minus 1. So here the ending index will be 10 minus 1, that is nothing but 9. Okay, here we are printing that array and again we are getting the same thing. So in that way also we can do that, just not passing start and stop separately, the system will automatically get that. Now what I'm doing is, if I want to add steps in our range, so what I'll do is I'll pass the start value, stop value and the step. So here the start is 0, stop is 20 and the step is 5. So 0 plus 5 is 5, then 5 plus 5 is 10, 10 plus 5 is 15. But if I do 15 plus 5, it will become 20, but here my stop is 20 minus 1, that is 19. So here the last value we'll have is 15. Another function we have is line space. Okay, so what happened whenever we want to get any values between two value with the equal interval. Okay, so for that we use the line space. Here as well we also provide start, stop and the number. Number will be our number of values that we want. So by default is 50. So let's say we have np.line space. Here I am starting from 0 and ending to 5. as I haven't passed the number here, so it will take 50 value. All these 50 value have the equal interval. Okay, so these are in equal interval. So how basically it get generated? We have this formula. We do stop minus start divided by total element minus 1. This way we'll get the first value, and if we add the same value in this, we'll get the another, and if we add one more the exact value in this, we'll get another, and so on so forth. We'll get the complete array list. Okay, again what I'm doing is I'm passing the step also. So I'm saying just give me number between 10 to 20, and the number will be 10. Okay, so this will divide all the number between 10 to 20, and the number will be 10 in counts. Similarly, we have np.zeros function. So what it will do is it will return a matrix with number of zeros. So in zeros function we pass the number of rows and column. Okay, so it is nothing by 3 by 5 matrix, where 3 are a row and 5 are columns, and all the elements inside that matrix are zeros. As well as we have np.ones, which will fill 1 instead of 0. Okay, so the function will also work same, but here we pass ones and the number of row and column again. Here one more interesting function we have is I is nothing but it returns a diagonal value, like all the flag in the diagonal will be 1, rest will be 0. So what I'm doing is I'm getting a matrix of 5 by 5 and telling that it is an np.I, like the value inside that matrix has diagonally 1 and rest will be 0. So far we have seen that how we can get the values in different way. Now we want to reshape our array. Okay, so what I'll do is I have one more thing, that is here np.reshape function. So what it will do is, let's say we have an array of 0 to 9. Okay, and we want to reshape it in a matrix. So initially it was a 1D array, and now we want to convert into a 2D array. So what I'm doing is I'm just passing the value and providing the number of row and column. But here the important thing is that we have to make sure the number of row and column we are passing should be equal to if we multiply these numbers, should be equal to number of the 1D array. Like this is 5 into 2, that is 10. So here we should have 10 element, then only it will convert like this. Okay, so again we are getting the same, but here I'm trying to do is 2 by 6, that is 6 into 2 is 12, but I do not have 12 element inside that array, so it will not convert that into a 2D array. Now we can also apply some trigonometric functions with our NumPy. Okay, so how we can do is like we have np.sin 4. Okay, so what it will do is it will get the value of sin 4 which is inside the np. Again, to get the value of cos 4, to get the value of tan 4, like we have this. So as we all know that the sign 0 is always provide us the 0. So let me give us so this way the sign 0 has given me the 0 value. And we also have some exponent here, what it is, we have exponential function. So we pass x2, so x2 is nothing but exponential of 2. Okay, so it will give me the value of exponential 2. Along with that, we can also apply the exponents function with the array. So it will return the exponent value of each value inside that array. Okay, next we have logarithmic. Yeah, of course we can also apply all the logarithmic functions with our NumPy, like log2 value is this. If I want to get the log10 value, of course we know this, so this is like this. right? Log array 5. So in array we have 3 values, okay, and I want to get the value of all the these values, so this way I'll get it. Now we have log with base 10. So what we do is we provide base here, okay. So I think by default it is base 2, but when we give the specific base value, so it will get the value of base that value. So here log base 10 is log 8 base 10 is this much. Let's apply some arithmetic operation on array. So what I'm doing is I have list 1 and list 2 and I want to add both of list. So here it will just append the list 2 with the list 1, okay. And what if I want to get a range of 1 to 5 and printing that range, okay. Now I'm defining another list and printing that list. So in this way we got arrays 7 and 8. Now let's play with it. I'm performing addition. So to do addition, what it will do is, as it has become our NP array, so now it will add the values inside those array. So it will be 3 1 4 4 2 6 5 3 8, so on so forth. If we subtract, it is also applied. If we multiply it is also applied. Divide is also applied. Inverse, yeah, of course we can also do inverse by dividing that with 1, okay. We can also get power just using the power operator here. Now we have few operations with our matrix. What are that? Let's say I'm getting a range of 1 to 9 and reshaping it into 3 by 3 matrix, okay, and I'm printing that matrix. I am getting another matrix that has diagonal of 1, okay, and that is 3 by 3 matrix. This way I got 2 matrices. Now what I'm doing is I'm trying to add these matrix, subtract these matrix, multiply these matrix, and divide these matrix. So similarly all the operations will be applied here. Now we have some linear algebra matrix multiplication also. Hope you remember it, how we perform the linear algebra in our math. So here I'm getting a range of 1 to 10 and I'm reshaping it by 3 into 3 matrix, okay. So the first matrix I'm getting as matrix 9, that is this. The second matrix I'm getting as matrix 10, that is this, okay. Now what I'm doing is I'm getting the multiplication, which is nothing but our matrix multiplication. So here we provide at the rate symbol, which will apply the matrix multiplications, okay. We have used in linear algebra. So matrix 9 multiplied by matrix 10, so each value will get the matrix multiplication here with the row and column, column and row in those combination. Now what if I want to get the transpose? So I only write the np.transpose function, so it will just transport the our original matrix, and we can also pass just t instead of passing transpose. It will also give the transpose of the original matrix. We can also find minimum and maximum values inside the matrix just passing np.min function and passing the matrix name, np.max function passing the matrix name. So the minimum function in that matrix and maximum function in that matrix is made easy just because of these two functions. Now we have one more function, that is random.rand, as by the name suggesting itself, random is just getting the random values. We have two parameters here, d0 and d1. d0 represent the dimension which required for the array, and d1 is our optional values. Let's see with an example. We have random.rand5, so it will give a matrix of 5 random numbers, okay. If we run it another time, it will get some another matrix, okay, some another, and keep changing the value, right. Let's say we have a random of 5 by 5, so what it will do is it will give the 5 by 5 matrix with a random number. The value will also keep changing with all the times. How many times we execute the program. Now we have seen this. Okay, this is more or less similar. We are again getting the random of 5. This is also given the 5 by 5 matrix. What if I want to get the mean and standard deviation of these matrix? Okay, so what I'll do is I have one function that is mean, np.mean, and to get standard deviation we just pass std and pass the matrix here. So np.std will return the standard deviation of the function. Okay, so we have seen that how random works. Now let's work with a rand int. So rand int nothing but it returns a random numpy array whose elements are randomly from low to high range. Okay, so the low we pass a number, high we pass the number, and the size we also pass. So the lower number is from 1, higher number is 5, and the number of element will be 10. So all the time it will keep replacing these value and generating the value between 1 and 5. Okay, I mean 2, 1 and 5 minus 1, that is 4. Here what I'm doing is I'm trying to get into a matrix. So I'm saying that okay, 1 is initial number, 9 is our ending number, and the number of element will be 5 by 5. So here it has considered as 2D array. Okay, now what if we want to access entries of those numpy? So what I'm doing is I'm again defining a rand array with 10 random number, and I want to access 6th index. So index always starts with 0, 0, 1, 2, 3, 4, 5 and 6. As this is at the 6th index, so it will return the value of our 6th index. And what if I want to pass keys like this? So what it will do is it will start from 0, 1, 2, 3, 4. Okay, starting from here 5, 6, 7, 8, 9. So ending to 9. So our starting index and ending index is this. Now what if I want to get the value a range of starting with 3 ending with 9, and the step is the number of values are 3. So first it is printing the access range, that is this. Then what I'm doing is I'm passing this np.arange with random array. Okay, so it will get the random array, and then I'm passing the np.arange with a rand array. Rand array is nothing but a random number of 10 digit. Okay, so now we have updated these values. We can also access arrays using some logical operations, like if we have an array and we want to check that if rand array is greater than 0. Okay, so if this is the case, then return true, else return false. So it will check all the element and check the condition, then return the value accordingly. Right, we can also do in this way. Instead of writing separately, we can write with print statement itself. So it will take a random array, and we are checking that if random array is greater than 0, then only say okay, these are the value, else give other value in the other print statement. So these are values greater than 0, these are value lesser than 0. Now what if I have to access entries in the matrix? So what I'll do is I'll just pass the index number. Okay, so to get the first row, I'm passing first here. Okay, to get the second, I'll definitely pass second. But if I want any particular, so we can define the row and column value. So as index start from 0, 0 to 1. Okay, so this is first row, then 0 to 1, this is first column to second column. That means our first row and second column, right? So the value we will get is this one. Similarly for 1, 2, so what it will do is it will just return the value as we got here. It is nothing but give me the value from 1 and 2. So how many values are there? Obviously there is one value 0 1, and at the position of 0 1 2, this is the same value again. Okay, so in the both way we can get the value. Now we can also do some slicing here to access these value. So just give me row 0 to 1, okay, and just give me column from 1 to 2. So there are 2 rows and 2 column. Okay, now we can also do the same thing with again applying logical operator here. Okay, so if the value is greater than 0, then just give me the rand matrix, okay, greater than 0. If we want to lesser than 0, then just passing less than value here. Okay, we can also modify the entries in that array, just accessing the column particular cell and passing the new value. So this is my third row and fifth column, and update this value with 5. So this way this will update the value. Again, this is my 0th column and second value, update this with 2 3. So here 2 3, what does it mean? At 0th index fill 2, at 1 index fill 1, because the index will go 2 minus 1. So 0 and 1 will replace by these values. What if I want to check the condition and update the value? Yes, we can do that. I'm checking that if the random array value is greater than 0, just update this value with 65. So all the value inside that matrix will get updated with 65. We can also modify the entry whenever we are working with our matrix. Okay, so the logic will also remain same. What I'm doing is I'm accessing the value. Just give me first row and third column, okay, and third row and fifth column, right, and just place 0. So let's say we have this initial matrix. What I'm doing is I'm accessing first row and third column. 0 first row and third column, 0 1 2 3. So this is our 1. In the place of that one, it is 0 updated. Okay, but always remember that we haven't passed the ending here. Okay, so that is why it will get the value and keep updating the value unless and until there is an ending value. So from first and third, just keep starting update this value as 0 0. For 3 and 5 also update this at 0 and 0. Okay, now let's say what I'm doing is if I want to extract the first 2 rows and first 3 column from the matrix, so how can I do that? To get the first 2 rows, I'll get 0 to 2, that means it will return 0 and 1. Okay, to get first 3, so 0 1 2 is there, so we will specify this in this way. So this has become a row, this has become a column. So 0 1 row I need, 0 1 2 column I need. Now what I'm doing is I'm saying that just return values inside that matrix and just update all the value with 1. So what I'm doing is I'm not passing any starting and indexing. It is considering all values and updating all the value with 3. Okay, what happened to rand mat when we change the submat? Okay, so what I'm doing is as I have updated this submat value, so in the rand mat matrix you can see that the value that I have updated is also reflecting here. Okay, so hope you remember that rand mat 3 that we created, and this is happening just because we got this sum matrix here. Okay, so just because of this sum matrix it has updated, and the update value is also reflecting in our original value. But to prevent with this type of condition, we also use copy function, which will copy the same array and we can update the value with our copied data. Okay, so what if I want to save and load the NumPy? So yes, we can also do that. If I working on Google Colab and I want to save the file that this matrix, so I can import the Google Colab here and get the path. Okay, to get the path we just mount to the drive, and once the path is driven, then we can normally create our matrix here. Okay, and we can pass the command that is np.save, so it will save the data inside this path. Okay, and as the file name, so the matrix will be there. We can also try with locally. Instead of passing this, we can directly use np.save, and we can simply give the path, so it will also save the same in our local drive. Right, save ez is also useful because it has the advantage when we use save ez, because it can store several arrays and matrix into a single file. Okay, which could be uncompressed or no npg format. Again, we are loading with two different files, that is npy and npz. Okay, both file will get loaded. Right, we can directly print them because once they are loaded we can directly get the array in this format. Okay, you can also try this. If there is any error that you get, please do comment below. I'll definitely give the feedback on them. Right, you can also please try locally whether it is saving locally with your computer or not. And last but the not least, what I'm doing is I'm loading the first matrix at loaded multi, because I got the loaded multi here, and getting the second matrix at loaded matrix randint matrix 2. Okay, so this is what we get the particular matrix name inside this file, right, from our loaded multi, because in npz we'll have two files, so we can get separately them, and we can perform all the tasks with separately. At the last, as we have loaded the file, but we can also save using the text, like we can if we don't want to open the file and we want to perform some operation without opening it, so we just read the file, and what I'm doing is I'm passing the random matrix 1 and saying that the delimiter should be comma, so we are separating the value with comma. Here as well we are doing with that, and it will simply return the Python array.